Hi, everybody. Welcome to week one of ELNC1632, which is distributed power generation and energy control. I trust you've read the textbook, sections 24-1 to 24-6. We're going to go over the PowerPoint for week one today and cover other details in our live session this week. So, Ontario generation capacity output and the grid. So we want to know, why is embedded power or distributed power so important to Ontario, North America, and the world? And what are some of the goals of distributed power generation? So some of the goals are improved system reliability, more smaller generating stations, reduce energy costs, okay, for efficiency, for fuel type, improve capital payback, reduce construction timelines, sell power back to the distribution system, and generate renewable power. So embedded power, distributed power, those could be anything from a farmer having a windmill, a homeowner having solar panels on their roof, or the small companies that have their own renewable energy, or towns in remote areas that set up their own smaller generating stations. So why the grid? Why distributed power? Why backups? So on August 14, 2003, a day I remember clearly, an incident in Ohio shut down a major portion of North America. It lasted up to 3 days in some areas. So that exposed an aging system. It exposed that we did have an energy security problem. Okay. And what has happened since then? Since that day, August 14, 2003, what has happened in North America to mitigate the effects of that happening again or prevent it from happening again? So not long ago, the grid had aging equipment. It was not very robust. Blackouts happened often and took a while to get power back to customers. Okay. So Digitization and Energy, this report is put in your Blackboard folder under week one. So I invite you to check that out. The traditional grid, generating plants, substations, transmission systems, and distribution systems. Okay, so this is something we're going to be talking about all semester. The traditional generating systems, we have dams and waterfalls, or hydroelectric plants. We have burners, which could be either coal or natural gas, or cogen stations that we'll talk about later, and nuclear power. Okay, but essentially they all drive turbines, they all drive generators and get power to the end user. This is a graph of typical demands during the winter and the summer. So even though the amount of the demand is higher in the winter, the peak times are generally the same. Okay, the peak times are generally the same. So, advantage of interconnected systems. One is stability. And again, like I mentioned earlier, it's better able to withstand a large disturbance. Continuity of service, for the same reason, and economy and efficiency. So different generating stations have different efficiencies, and we could take advantage of the more efficient ones at the right times. Okay. The grid, okay, and I'm putting up my fingers, doing a little quotation thing. The grid is the entire electrical power generation and distribution system in North America. So you'll often hear people talking about the grid, just like we talk about the internet. It's there. It's all of North America. The grid has different levels of transmission and distribution systems. So these are their operating levels. Just a pictorial idea of how generated electricity makes its way around Ontario. And again here, the types of plants that we have burners, we have nuclear plants, we have hydro, we have cogen stations. Okay, and we'll get into all that a little more in this presentation and during the course. But this is just an idea of where electricity is generated throughout Ontario. Imports and exports. We're talking here about how much Ontario imports and exports every year. And we do export more than we import. And I'll show you another table on that. If we go here, this is our import and export report. And this is for September 1st, 2020. Okay, so this is what we imported and exported from Manitoba, from Michigan, Minnesota, New York, Quebec. Okay, different places in Quebec, and you'll see that we exported more. If you look on the right, we exported over every hour of the day on September 1st, 2020. We exported more than we imported, except for a few hours late in the afternoon, where we had some peak demand. Okay, so that report is available at ieso.ca, and we'll refer to that site too. So, again, our exports and imports over the course of the day. Okay, and we are exporting more than we're importing. The grid itself, the grid in North America is divided into three major sections: the Eastern Interconnect, the Western Interconnect, and the Texas Interconnect. Okay, and they are generally isolated from each other in case of a catastrophe. So this is your map with the interconnects. So we have the Western, the Texas, and the Eastern, and we also have the Quebec interconnection and the Alaska interconnection. Okay, but you can see it's broken up into major sections. And here we just broke it up even further. So we are in there. Okay. So the Eastern Interconnect is made up of these sections, subsections. Again, we are Northeast Power Coordination Council. So here is how power is generated in these areas. Okay, so Ontario is very dependent on nuclear power. Quebec is very dependent on hydroelectric generated power. You'd be interested to know, and it says here the US, the grid is still heavily dependent on fossil fuels. In the States, last year, there was still 30% coal generated electricity in the States. And the United States also still uses a lot of natural gas. In Canada, only 5%, or, oh, sorry, 9%, only 9% of hydroelectric power, or sorry, 9% of generator power was coal. So that is interesting note to remember. Only 9% of electricity generated by coal burning generating stations in Canada. And coal is only being used in Alberta, Saskatchewan, New Brunswick, and Nova Scotia. And let's continue. So Ontario's total capacity is 36,000 megawatts. Okay, 36,000 megawatts is our total capacity in Ontario. The IESO is a very important organization. It's the Independent Electricity System Operator, and they oversee all of electrical generation in Ontario. And if you go to ieso.ca, there's a lot of interesting information, and we'll be referring to it during this presentation. So, right now in Ontario, nuclear energy accounts for 35% of our power. Hydro, 23%. Okay, gas is still at 28%, natural gas. We get 12% from wind power, and you'll see the breakdown of that when I go to a report in a few seconds. So this is our installed capacity, okay? This is embedded generation, so on a distribution system, which means this is what's coming from the smaller local generating stations around Ontario. So it should not be a surprise that a majority of it comes from wind and solar, because that is what a lot of farmers and homeowners and property owners are installing. Okay, and then there are little hydro stations around Ontario, smaller natural gas stations, but the majority of the distribution or embedded generation is coming from wind and solar. Okay, so base load and demand generation. So the base load is, if you see from this graph here, our base load is what is pretty much needed at all times. It's pretty much needed at all times. The demand or the peak is what's needed only at certain parts of the day. Okay, so the nuclear and the hydro take care of the base load generation. And a lot of the gas and smaller hydroelectric stations will come during periods of high demand. Okay, so SC stands for simple cycle gas turbine generator. So that's just taking the heat coming from the gas and using it there. The combined cycle is taking the heat from the gas and it's taking the escape heat to power steam turbines to get more electricity out of that station. Okay. So we have, if we look at this graph, we have our constant base load needs. And then we have intermediate demand. So this is demand that's still taking up most of the day. And then we have our peak. Okay? Then we have our peak. So if we go to the IESO website, we'll see here. So this is what's going on. Here's what's going on right now. I am recording this on September 2nd. So we see here that a majority, if we look across the bottom two, a majority of our power is being taken care of by hydro and nuclear, as I said earlier. Okay, now in this portion here, gas is kicking in a little more, and then we have wind and solar that are topping up along the top. Okay, but you see from this graph that it is hydro and nuclear that are taking care of the base demand. And then as it increases, so let's look here. The peak is happening around 4 o'clock yesterday. Okay, 4 or 5. So I want you to remember that. 4 and 5, so it started at 8 o'clock, it started increasing, and then it went back down around midnight. Okay, so if we go to the actual report, I'm going to try to zoom in on this. Look, this is an hourly report of what we're using for each station. Okay, so if you look at nuclear, the nuclear output is very close to its capacity, and it's very steady. If we look across the course of the day, it's pretty steady. That's taking care of the base. Now, if we scroll down to the hydro, we have our hydro here. So hydro is not operating at full capacity, but it is a fairly steady output. Okay, and then we got a little more here. As I showed you over here, the hydro did go up in this middle section, and it goes up here. And it peaks at about 4 or 5 o'clock, and then it goes back down again. Okay, now I told you to look at when the gas starts to increase. Okay, the gas output. So if we come back here, I'll go to gas, the total gas. There we go. And we'll see that gas is running fairly low, and then it starts to increase, and again peaking at around 4 or 5 o'clock, and then going back down again. Okay, so the gas only kicks in when the demand was there. All right, now we have here wind and solar. All right, I'm going to tell you something fairly obvious in a minute, but the wind we are getting, if we go down here, sorry for all the scrolling. So wind here, wind is a variable source, okay? It's not always windy, basically what I'm telling you. So we are getting some feed from the wind, okay? And then you'll see something fairly obvious here. Solar. Okay, solar, you'll see that there is no solar from 1 a.m. to 6 a.m. pretty much because it's dark. And then same here, starting at 7 and down to midnight. So that would explain why the solar is only peaking when it does. It is not something we can depend on. Okay, it's not something we can depend on. So all that is at IESO if you want to look into that further. Okay, so the next few slides, you can review them. They describe our nuclear source, gas, hydro, okay? You probably had the misconception since you were young, growing up in Niagara, if you did, that Niagara Falls powered the whole eastern seaboard, and that's not the case, as you can see, okay? Niagara Falls is very important on both sides of the border, but there was always this myth that Niagara Falls was the be-all and end-all of electric generation in Ontario. So, okay, wind and solar, again, we have a capacity of 5,000 megawatts, but it's variable, it's not dependable, but when it's there, it's good to use. And just an example is that there was a solar eclipse on this day, and you see what happens to our solar output. Okay. Bioenergy, there is a link at the bottom that you should check out about bioenergy, okay? So we have biomass, biogas, and biodiesel. Those are terms that you hear a lot when companies are bragging about their environmental consciousness in different commercials, but you should take some time and read about those. Fuel cells. I really encourage you to go watch the YouTube video at the bottom of the screen. It is very interesting. Okay. Our long-term energy plan. This is what we expect our installed capacity to be at 2025. Okay, so this is where they are hoping to go. Okay, an increase in renewable energy, less of a dependence on nuclear, and what we're trying to do is we're trying to shave off the some of the peak demand at certain times, okay? So that is done with higher efficient appliances, higher efficient end user equipment, education, and the way the billing works. And we're gonna talk about that during our live session. So energy production forecast, okay? And then 2032. Look at what is going to play a big role in their projection for 2032. It's conservation. And conservation is going to play a major role in where we are going with this. So this video and this PowerPoint will be posted to Blackboard. And we will be discussing during our first live session, assignment 1, as well as an outline of the course, where the course is going. And I look forward to seeing everybody then. Have a good day.